I know most of you that are logged in, but I started as a professor of practice a year ago, last August. And today I'm going to briefly talk to you about a visual perspective on geospatial uncertainty. And I'm going to go over just two projects, but kind of a overview of them. Obviously, I don't have time for details, but I wanted to start by giving you guys a little bit of background about how I came into this. And I read a paper in 2011 when I was a PhD student from Herbertson, and it was published in 1905. And there were a series of maps, and this was one example. And it struck me how precise these boundaries were. And I thought, well, it's not like in any of these maps, whether we're talking about land cover, seasonal rainfall, it's not like you jump over a line and all of a sudden, forest is suddenly gone and there's these crisp boundaries. And not only no transition zones, but no uncertainty on the maps. And so I started to think, why aren't people showing uncertainty, whether explicitly visualizing it or kind of talking about it in visualizations? And so I started to research what is uncertainty. And of course, it's inherent in all of our geospatial data that we interact with, whether we're talking about, if we're looking at this pipeline on the left side, when you collect your data, you can only be so precise. When you derive or model farther down the pipeline with the data, you can incorporate more types of uncertainty as well as visualization. When you're thinking about this limited display space, our computers, for instance, and trying to visualize the complexities of the world in a small screen. And so we're constantly adding uncertainty. And, why aren't researchers kind of talking about it more, visualizing it more? And one of my first projects that I sought out to do was, I called it Domains of Uncertainty Visualization Research. And as I started to read tons of articles on the field, I started to develop an unstructured list. And so I would just write down all of the topics and concepts covered. And eventually I decided to follow the affinity diagramming method, which is a ridiculously fancy term for basically, if you imagine you had a bunch of flashcards with just concepts on them on a desk, and you just wanted to organize them first thematically. So you have various groups that are more related than others. And then you start to kind of flesh out a taxonomy, or maybe not quite so formal, like a classification of the field of uncertainty visualization research, or I should say geospatial. And so what I ended up with is developing that classification. And I went to several different conferences and presented on the kind of hierarchy or classification that I saw in the field. And I organized a couple international workshops on uncertainty visualization and got feedback from other researchers. And I eventually kind of finalized a diagram, I guess you could say. I call this a visual summary of the entire field based on, this iterative design over several years. And this diagram, in a way, to me, was very powerful because, just in one look, I've kind of summarized the field based on feedback from others. And I'm not going to talk a lot about what all the specifics are here, but I will just briefly. You could see I've kind of thematically organized it by hue or color, and green, blue, and purple. Where green, I talk about user effects. That just means, and kind of ignored a lot in cartography research until recently. When you're thinking about how people interact with visualizations, for instance, maps, there are things that you have, such as prior experience, individual differences. You may be better at numbers than me, that impacts how you interact with the visualization and how you can reason about the data that you look at or make decisions. You may have a different affect than me. And those are kind of those prior experience or individual differences. Visualization techniques, straightforward in the blue. These are just the various ways we can visualize uncertainty or evaluate them. And then finally, the other kind of topics in this research field are stimulus effects in purple. And these are ways that the stimulus or the visualization can affect you as the user. So you might have decisions, you might have some kind of comprehension of the data or the map, some sort of affect. And so this is kind of just wrapping up the whole field in a diagram. And then what I did is I started to classify articles. So you could see here, these are 8 different articles. And what's nice about visualizations or diagrams is just at a glance, you could see all of the topics that they cover in the field That's not to say that this is just a comprehensive list of every topic, but generally agreed upon by a lot of researchers. And, I shade in the colors, and then you can know right away what each of these articles cover. And I did with another researcher, we started to create a website where users could go in, create their own graphic if they have a new article coming out, and they could use it in their presentations and, sorry, I'm sick. Visually show quickly what they are covering. And what I'd love to do is start to look at change over time as I've classified these articles and see what people are looking at now compared to before. Are we missing some areas? And moving on to another project that I worked on, and I'm still kind of wrapping this up at the end, was a hurricane flooding visualization. And my attempt here, I'm really interested in the user effects section. And so that's looking at prior experience, abilities and so on that you have as an individual and how that impacts how you reason with and interact with these visualizations. And luckily for me, or perfect timing, storm surge or flood maps were released in 2014 from the National Hurricane Center. And they stated storm surge is often the greatest threat to life and property from a hurricane. And what was interesting about this is that they released this map to millions of people without doing any evaluations. And I spoke with the people who actually worked on these maps, and the only type of evaluations they did before it was released to the public was more the color schemes. What colors look good? What do people prefer? And they didn't actually see whether people could read the map, they could make sense of it, how does it impact the decisions they make? And so I sought to kind of do a preliminary analysis on this. And what I had to do, if any of you have kind of looked at maybe more like psychological studies, you have to strip down the stimulus first, and you can start to add more realistic elements later on. And so I removed roads, but I took real flood data from them. I used the same exact categories and colors, the same legend and layout, and I created the maps again. And the reason I took away the roads is because I wanted to ask them questions about whether they would evacuate for specific locations on this map, but I didn't want the roads to be an influence because I can add that later and then see how that changes the way people make decisions. So here is how I kind of varied what I call the stimuli, just the map itself. We had the various flood depth, which are the colors that the National Hurricane Center assigned, the blue, yellow, orange, red, or the hues. And there were 2 surveys with different probability of flooding. So here, uncertainty is not explicitly visualized on the map. The users are told what probability of flooding is because I wanted to see when they're uncertain about something, how does it impact their decision making? And then there are 2 scenarios for flooding, mild and more severe scenarios. And then just like other psychological studies, there are points on each map. They're asked whether they'd evacuate, and the points are randomly placed within each of these flood depth colors, and you balance it with the severity of flooding and different coastline orientations. And all of this is just kind of for repetition in the study to make sure that there's not one specific thing that influences how people make decisions. So what I used in this study actually was Amazon Mechanical Turk, and it was starting to get really popular when I first started this for educational studies. And the reason I did this, in a lot of cartography kind of experiments or surveys, traditionally a lot of researchers will use students in their class. And while that's nice, and Amazon Mechanical Turk might have its own limitations, using students and asking them, many of whom may not be homeowners or experienced hurricanes where I was inland, I wanted to use a population, and I filtered it by those living on the East Coast in areas exposed to hurricanes. And I filter them randomly then to one of the 2 survey conditions, 10% or 30% chance of flooding. And then I asked them whether they would evacuate in each of these scenarios, and there was a series of maps with different locations. And I'm not going to go through all of the stats and everything, but I just wanted to talk overall about the findings that I've seen. And what I ended up doing, this was more of an exploratory analysis. I did have hypotheses because I collected data on kind of prior experience with hurricanes, both negative and positive. I measured things like availability heuristic, which is a reasoning-based strategy that people who have experienced, in this case, a hurricane recently, are more likely to overestimate the probability of like a severe hurricane, for instance, happening again. And so I measure things like that. However, statistically speaking, none of those kind of user effects came out in the data or the results. But what I did find in study one, nothing to do, no differences between a 10% and 30% scenario. However, the one thing that was statistically significant and odd to me was that people in, let me see if my stylus works here, people in this kind of orange band, when they had locations in the orange band, in the mild scenario, they were more likely to evacuate than in a severe hurricane scenario. And I thought, why would people want to evacuate in a mild hurricane in the same kind of color band, this orange color here? And looking at the map, I realized, okay, I used real data. What if it's because I just, it's touching the ocean? So what if I just, on my next study, I run the same kind of experiment and I close it, and you can see that here, closing that red portion there. Maybe people will make different decisions. So I ran the study again with a different set of participants. Same exact findings. In the mild scenario, people were more likely to evacuate than the severe. And so I had to sit down and think why this was happening with a majority of the participants. And what I realized was one of the heuristics or reasoning-based strategies that people may have for making this kind of situation or decision is that perhaps in the mild scenario, you could see these bands are very thin, the colors. There's not as much red or severe flooding, not as much orange. Perhaps it's because they're closer to the flood source, which was the ocean. So what happens if I do a follow-up study and now I just measure how far they are from the flood source and see if that's how they make their decisions? And so in study 3, I was able to see that indeed, even in the mild and severe scenarios, it didn't really matter what flood height category they were in. As long as they were close to the ocean, they consistently chose to evacuate. The farther away they moved, less likely they were. And so, an interesting study, and obviously, well, I put in the next slide, for future steps, I need to start to incorporate more realistic elements, such as roads, to see how that may impact, obviously being closer to a road, you can get out quicker potentially, how that might impact decision-making. And another big thing is I want to look at the qualitative data more, because I've focused so far on a lot of my quantitative data and see, some of the responses I've gotten from people. And then finally incorporate more realistic graphics and videos to see how that might impact decision-making. So where does that leave me? Future research. I love looking at individual differences and what it is that makes you, and how do you make decisions different than someone else when you interact with visualizations. And I'm also really interested in designing visualizations to help people comprehend data, not just uncertainty, but data in general. And I'll kind of wrap up here the next few slides. I want to develop methods to visualize data to go beyond what I call a surface level understanding. Here, I do say uncertainty, but just data in general. So surface, what I mean here, look at map reading, for instance. If I asked you to look at colors on a map and match the colors to a legend, that's easy for most people. If they did it, okay, I designed a good map visually. They can map the colors or match the colors, and they can compare two side-by-side maps or two locations. But does it mean they understand the complexity of the data? Maybe not. And so what I'm really interested in is designing visualizations to help people get a deeper understanding of uncertainty or the data. And I'm gonna wrap up here with this example on the power of visualization. So I have a scenario for you. The probability that a woman at age 40 has breast cancer is 1%. The probability that the disease is detected by a mammogram is 80%. The probability that it's misdetected or you have a false positive, meaning the test is positive but you don't actually have breast cancer, is 9.6%. So if a woman at age 40 is tested as positive, what is the probability that she indeed has breast cancer? And you guys don't have to shout it out, but you could think about that for a moment. In this study that came up with this example, out of 100 doctors that they asked, 95 estimated the probability to be between 70 and 80%. The correct answer is 7.8. Nowhere near that. And these are the people who are supposed to be communicating this to patients. And so I just want to show you the power of the graphic. So here you can see every gray dot, that's one individual. There are 1,000 individuals here. So probability that a woman at age 40 has breast cancer is 1%. Those are all the orange dots. Probability that the disease is detected by a mammogram, 80%. These are the smaller kind of sliver here with orange dots. Probability the test misdetects the disease is 9.6%. You're false positive. So here on this graphic, you can see who tests positive and actually has breast cancer. It's just these small orange dots with the black outline here. So much easier to see that this population within this population is not 70 to 80%. So this just goes to show how powerful graphics and visualizations can be to convey really complex information. And that's what I really want to, going forward in research, focus on.